Sam, do you think the Job Guide 360 interview guide is worth recommending to people looking for jobs?
Absolutely. It's clear, thorough, and really simplifies interview preparation.
Welcome to the deep dive. We've just gone through a massive stack of expert interviews and research. Today, we're zoning in on what might just be the toughest gig in tech.
Oh yeah, which one's that?
Being the software architect at a startup. You know, super fast, super constrained.
Oh yes.
Yeah.
The pressure cooker. Our sources really map out a survival guide, it feels like.
Yeah.
Brutally real-world stuff.
Exactly. And this material we processed, it's not about textbook theory at all.
No, it's pure pragmatic decision-making, almost like a master class. It's really the playbook for balancing that insane need for speed for shipping now against the fact that, well, your product has to survive potentially huge growth later.
So our mission today is basically to distill all that down, get those core philosophies, the practical steps.
Right, give you that shortcut to understanding how the experts lay foundations that are, quick but also resilient.
We're going from zero to reliable, basically, and fast. So let's get into it. Okay, picture this classic startup scene. Greenfield product, brand new idea. You've got maybe, 3-4 months till launch? And your engineering team is tiny.
The classic scenario.
So how do you even approach that end-to-end MVP build? How do you avoid painting yourself into a corner right away?
Okay, the core strategy is simplicity, but simplicity amplified by maximum leverage. You have to start by ruthlessly narrowing down the scope. Just the absolute core user journeys.
Nothing extra.
Nothing. And technically, you almost always opt for a modular monolith. The goal is pure speed.
Modular monolith. Okay.
And crucially, to keep that tiny team focused only on features, you lean hard on managed cloud services. Right from day one. Think auth, databases, queues, anything you don't have to build.
You're basically buying operational headroom. Makes sense. You don't want to hire a DBA on day one.
Precisely. And beyond just the code architecture, you need process leverage too. Get a really thin CI/CD pipeline up early.
Yep.
Immediately. And drive all your environment creation through infrastructure as code, IAC, Terraform, CDK, whatever.
Automation from the start.
Yes. And here's the bit people often skip, but it's vital. Document your key architectural choices. Now, use architecture decision records, ADRs. Little text files are fine.
Why so early?
Because when things inevitably get crazy 3 months down the line, and they will, that context, that why behind the decision is gold.
Okay, that brings us straight to maybe the biggest early debate. Monolith versus microservices. Everyone hears scale and thinks microservices, right? But you're saying start simpler.
Absolutely. Because microservices, especially early on, they're a tax. A huge tax on complexity, on communication overhead, on operations. Things a small team just cannot afford.
So the modular monolith is purely for speed.
It's for speed, yes.
Right.
But the modular part is the key. That's the trick. You have to think of it like a house built with movable internal walls, not just one solid block.
Okay.
You must enforce clear bounded contexts, define API seams within that single monolith. Discipline is critical here.
So you're building that separation of concerns internally, right? Even if they're deployed together.
Exactly. Even if they share the same deployment artifact. And that design, that is what enables the future escape hatch, the strangler fig pattern.
Right, the strangler fig.
So when one specific piece, maybe it's your billing engine, maybe it's some high traffic reporting thing, when that part hits a scaling bottleneck.
You can pull just that piece out.
Yes. Because you already have those clear seams defined. You can carve out just that one service into its own microservice later without needing a massive, terrifying rewrite of the whole application.
It's like intentional procrastination on complexity.
It's preserving optionality. You're scaling your team's focus first, not the infrastructure prematurely.
That's a much smarter way to think about scaling, I think. Okay, let's shift to data. How are you choosing between SQL, NoSQL, maybe a hybrid, especially when requirements and access patterns are, still fuzzy?
You have to start with two things: your consistency needs and your access patterns. If you absolutely need strong transactional consistency, ACD guarantees, complex joins across multiple tables.
Which is true for most core stuff, like user accounts, payments.
Exactly. Then you really have to stick with a solid relational database. Postgres is usually the go-to. It's mature, reliable, everyone knows it.
But relational databases aren't always the best for, say, massive write volumes or super high-scale reads, right?
That's precisely where the hybrid approach often makes sense. You bring in managed NoSQL, something like DynamoDB or Mongo Atlas, specifically for those high-write scenarios, or for data that's more document-centric.
Can you give a concrete example?
Sure. Like maybe your core operational data, users and orders, lives in Postgres. But then maybe you have event source materialized views, things that need super fast reads for a dashboard and can handle maybe a second of lag.
Right.
Those might live in DynamoDB for that read scalability.
Got it. And this choice, SQL versus NoSQL, it kind of forces you to deal with the CAP theorem, doesn't it? Can you break that down practically? Not the textbook definition, but the actual dilemma.
Right, the CAP theorem. It basically boils down to a fundamental trade-off you have to make when, not if, but when, your network partitions. Meaning parts of your system temporarily can't talk to each other.
Which always happens eventually.
Always. So the theorem says you have to pick 2 out of 3. Consistency, availability, or partition tolerance. Since you must tolerate partitions, you're really choosing between consistency and availability during that partition.
Okay, so network's broken. What's the choice?
It depends entirely on the business impact of getting it wrong. If you're designing the system that handles, say, financial transactions, your payments ledger.
You need consistency badly.
Absolutely. You choose strong consistency, you'd rather the transaction fails and the user maybe sees an error, than risk the system processing 2 conflicting payments or losing money. You accept a potentially slower, stricter right path.
Okay. And the other side?
But if you're designing something like a social media feed, or maybe a read-heavy analytics dashboard where being a second or 2 out of date doesn't really matter.
Availability is more important there. People want to see something.
Exactly. You choose availability, you opt for eventual consistency, you prioritize the user being able to access the service, even if the data is slightly stale for a moment. It's a very pragmatic, business-driven choice every time.
Okay, moving beyond just the initial foundation, startups, well, they swim in ambiguity, which is kind of the architect's nightmare, right?
Oh yeah, constant ambiguity.
You're always being asked to design features where the problem is fuzzy, customer insights are thin. How do you use architecture to cut through that, to avoid, spending months building completely the wrong thing?
This is where the architect really puts on their risk manager hat.
Yeah.
The focus has to shift entirely to fast discovery. You can't afford to build blindly.
So what does that look like practically?
You work super closely with the product manager to find the absolute narrowest possible hypothesis you want to test and a clear success metric. Then, technically, you build only a clickable prototype or maybe a super thin slice of the actual feature, just enough for validation.
Not the final, polished, scalable thing.
Definitely not. A thin slice is really just the minimal scaffolding needed to prove or disprove that core concept.
And how do you protect the main application from this experimental code?
Crucial point. You isolate it completely. Put it behind an internal API gateway, maybe,
right,
and use feature flags extensively. This lets you roll it out very carefully, maybe just to internal users first, or a tiny beta group.
And then you watch closely.
You log everything. Usage, feedback, metrics. That data becomes your guide. It either validates the hypothesis, telling you you're on the right track, or it tells you very quickly, nope, pivot now.
Let's pivot ourselves to security. You're handling sensitive data, maybe PI. You have to protect it. But a full-blown security audit could take weeks, grinding everything to a halt. How do you do lightweight threat modeling effectively without killing velocity?
You need quick, high-leverage frameworks. Start by sketching out a rapid data flow diagram, DFD. Just map how the sensitive data moves where it crosses trust boundaries.
Okay, visualize the flow, then what?
Then you apply a framework like STRIDE. It's an acronym. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. You basically brainstorm threats against your DFD using those categories.
It helps you enumerate the likely attack vectors quickly.
Exactly. And then you focus on the practical highest leverage mitigations that you can implement now, especially using managed services.
Like what? What are the must-haves?
Enforce least privilege religiously using IAM policies. Encrypt absolutely everything in transit with TLS, at rest using managed KMS, key management services, centralize your secrets management, don't hardcode anything.
These cover a lot of the basics quickly.
They do. It's not perfect, zero-risk security,
Okay.
but it drastically reduces the most common immediate risks for a startup. And again, you document the controls you put in place and any known residual risks in a quick ADR. Visibility and accountability.
Okay, speed. Speed inevitably generates technical debt. We all know it happens. What's the expert process for managing that debt so it doesn't eventually just, sink the ship while still keeping that dev velocity high?
Yeah, you can't just ignore it or treat it as optional cleanup later work. It's not cleanup, it's risk management. It has to be visible, quantifiable risk.
So first step is making it visible.
Absolutely. Maintain a centralized, visible backlog of tech debt items. and tag them clearly by their impact. Is this debt creating a risk like a security hole or potential bug? Is it costing us money like unnecessary cloud spend? Or is it hurting performance?
Right. Categorize the pain. But then how do you actually get the time allocated? How do you sell that investment to founders or the product team who just want features?
You use a two-pronged approach. For the small stuff, the quick wins the Boy Scout rule. Fixes you find along the way. You bundle those into regular feature work. Just clean it up as you go.
Okay. Low-hanging fruit.
But for the bigger, high-impact items, you absolutely must reserve dedicated capacity, maybe 10-20% of each sprint. And you justify that time using metrics.
Data-driven justification.
Yes, you show them, look, addressing this specific piece of debt directly correlates with reducing our change failure rate by X% or improving our deployment lead time by Y hours. You have to translate code quality problems into tangible business stability and speed improvements.
That connection is key, making it about dollars, downtime, and delivery speed, not just code elegance.
Exactly.
Okay, one more classic startup trade-off. Build versus buy. Budgets are always tight. How do you evaluate spending precious engineering time building some component versus just buying a managed SaaS solution?
The primary deciding factor, almost always should be, is this capability part of our core differentiation? Is this thing fundamental to what makes our product unique and valuable to customers?
If it's not core.
If it's not core, if it's generic plumbing, like logging, monitoring, maybe even feature flagging or off, you should strongly prefer the managed service. You are buying speed, reliability, and features you likely couldn't build yourself for months.
But aren't you just trading that immediate dev time for a long-term vendor lock-in? That feels like a big risk for a young company.
It is a risk, absolutely, and you have to acknowledge it. But you weigh the time to value, the total cost of ownership, think over 12, maybe 24 months, and that lock-in risk specifically against the immediate cost of delay or the cost of building it poorly yourself.
Can you give an example where buying usually wins early on?
Authentication is the classic one our sources mentioned again and again. Building secure, compliant auth is hard. Buying a managed provider like Auth or Okta, it avoids massive compliance headaches, gives you features like MFA and social logins immediately, and lets you ship your core product weeks, maybe months sooner.
So you secure the immediate business advantage.
Yes. The architect's job here is to get the business moving safely now. You document the choice, you understand the lock-in, and maybe you even outline a potential migration path for if and when the company is stable and mature enough to justify building that capability in-house later.
All right, let's shift gears a bit towards operational quality. For that small, busy startup team, how do you realistically set up observability? Monitoring, logging, tracing, and maybe even service level objectives, SLOs. How do you do that from day one without just drowning the team in alerts and dashboards?
Yeah, you can easily overdo it. The key is to start lean and be absolutely ruthless about focusing only on what directly impacts the user experience.
So what's the minimum viable observability?
You absolutely must capture the basics, what are often called the golden signals. You need some basic distributed tracing to see how requests flow. You need structured logs, ideally JSON, that are easy to query. And you need fundamental service level metrics. Latency, error rate, and maybe saturation like CPU or memory usage. That's your foundation.
And SLOs. Service level objectives. Feels like you could define hundreds.
Don't. That's the trap. Define only one or two maximum to start. And they must be user-centric. Focus on the absolute core business flow. What really matters. Maybe it's the P95 latency for logging into the app or the availability percentage for successfully placing an order.
Things that directly translate to churn or revenue if they break.
Exactly. Metrics the business understands. And critically, just like with other infrastructure, you pick a managed stack for this. Use something like OpenTelemetry for instrumentation. And send the data to a hosted backend like Datadog or Honeycomb. Avoid managing your own observability infrastructure at all costs early on. Buy that operational capacity.
Speaking of infrastructure, a solid CI/CD pipeline and infrastructure as code strategy, that's like the circulatory system for a fast-moving startup, right? What does a good, reliable setup look like for a small team just starting out?
The sources were pretty clear on this. They strongly advocate for trunk-based development. Everyone works off the main branch, integrating small changes frequently via short-lived pull requests.
Keeps integration pain low.
Minimal pain. And your CI pipeline needs to be comprehensive but also fast. It should run your tests, yes, but also automated security scans, linting, and then build your deployable artifact. all triggered automatically on every push to main.
Okay, and managing the actual environments, dev, staging, prod, how do you do that safely when the team might be pushing changes multiple times a day?
Everything, absolutely everything, must be managed via IEC, Terraform, AWS CDK, Pulumi, choose your weapon, and ideally, you use GitOps principles.
Meaning the Git repo is the source of truth for infrastructure.
Exactly. Changes to infrastructure are made via pull request to the IAC code, reviewed, and then automatically applied. It gives you transparency, auditability, and rollback capabilities. And crucially, the deployment process itself must be automated using safe patterns, even from day one. Think blue-green deployments or canary releases.
No manual kubectl apply to production.
Please no. Manual deploys are where mistakes happen. Automated, safe, progressive rollouts are fast and reliable.
Let's talk APIs. Startup requirements, they shift constantly, sometimes weekly. How on earth do you maintain any semblance of API stability for your consumers, whether that's other internal teams or maybe even early external partners?
This is tough. The key is to design your APIs around the stable domain concepts that define your business. Things like users, orders, products, inventory, not around transient feature requirements that might change next week.
Anchor to the core business model.
Exactly. And the absolute golden rule for evolving those APIs is use additive changes whenever possible. If you need a new piece of information, you add a new field. You almost never modify or remove an existing field if you can help it.
Breaking changes are poison.
They really are. Versioning your API is complex and creates a huge burden on your consumers. You should avoid it unless a breaking change is absolutely fundamentally unavoidable.
Okay, but what if you do need to test a significant, maybe breaking change, or just roll out a new behavior to a few specific clients first?
That's where things like consumer-driven contract tests become valuable, to get early warning if you're about to break someone. And for rolling out changes gradually, again, feature flags are your friend. Or you can use opt-in request headers. Let specific clients explicitly ask for the very next behavior.
So you contain the blast radius.
You contain the blast radius, you get feedback from early adopters, and you can iterate quickly without disrupting everyone else.
You know, architectural influence often goes way beyond just technical brilliance. How do you effectively communicate these complex architectural decisions, these trade-offs, to the non-technical stakeholders, the product managers, maybe the CEO or founder? They care about results, not diagrams.
You absolutely have to translate everything into their language, which means talking about business outcomes. Always frame the options in terms of risk, time to market, and direct customer impact.
Less jargon, more business impact.
Zero jargon, if possible. Use simple trade-off tables. Visuals that map directly to user flows they understand. If you're arguing for technology A over technology B, the explanation shouldn't be about technical merits alone. It should be. Okay, choice A gets this feature to market 4 weeks faster, time to market, but it introduces this medium security risk we'll need to mitigate next quarter risk.
Make the trade-offs explicit and business-focused.
Explicit, clear, and tied to business value. And keep those ABRs we talked about earlier short, focused, and highlighting precisely those business implications of the decision.
Okay, to wrap up this section on quality and influence, the sources highlighted a really cool culture initiative that significantly boosted engineering effectiveness in one small team. What was that secret sauce?
Yeah, this was great. They introduced 2 simple things: weekly, informal architecture office hours, and a rotating design review process. Anyone could bring an idea.
What was key about it?
The key was the culture around it. They specifically welcomed early, half-baked ideas, not just polished, finalized proposals. It became a safe space to brainstorm and get feedback before writing a ton of code.
So catching flawed assumptions earlier.
Way earlier. And the measurable impact was actually pretty startling. They found it significantly reduced rework later on. It helped create a shared vocabulary and understanding through discussing these ideas and documenting them in ADRs. And ultimately, they measured about a 25% drop in their overall lead time for changes.
Wow. So architectural clarity and discussion isn't a blocker?
It's actually a velocity multiplier when done right.
Yeah.
#tag outro.
Yeah.
So if we boil down this whole deep dive, I think the core insight for any architect working in that high-pressure startup environment is, well, your job is fundamentally about making the most pragmatic, the most leveraged decisions you can.
Right.
Decisions that maximize speed right now, but crucially, do it in a way that deliberately preserves your options for future scale. You don't paint yourself into corners.
And how do you do that?
Mostly by leaning heavily on those managed cloud services we talked about. buying operational capacity and practicing incremental modernization, using patterns like the Strangler Fig to evolve a simple foundation over time, avoiding those huge, risky Big Bang rewrites.
Absolutely. It's about smart, incremental evolution. And to leave everyone listening with a final provocative thought, we pulled a fantastic conflict resolution scenario from the sources. Picture this. The architect is facing down the founder.
Oh boy.
The founder insists on skipping a critical security hardening step for a major new feature just to hit an urgent demo date. This puts the architect right in that classic bind. Business urgency versus, well, non-negotiable quality and security.
The ultimate stress test. So what did the architect do?
Well, the strategy wasn't just to say no, which often doesn't work. Instead, they proposed a really smart scoped compromise.
That's it.
The architect agreed, yes, we can hit the demo date, but they contain the risk massively. The feature would only be available behind a private internal feature flag. And crucially, it would only use sandbox data, no real customer PII.
Contain the blast radius for the demo.
Exactly. And the non-negotiable part. They secured a clear, explicit commitment from the founder that the full security hardening would be completed before that feature ever saw the light of day for general availability with real customer data.
That's clever. Meet the immediate business need, but draw a hard line on the real risk.
Right. That approach, using data, using scoping, finding ways to meet the business goal while fiercely protecting the essential security and quality baseline, that's maybe the ultimate lesson in real-world architectural influence. So the question for you is, how would you handle that negotiation when your technical conviction clashes hard with the business timeline?
Definitely something to think about.
That's something to mull on as you go build your next scalable empire.